Hey guys and gals, hello, 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 welcome back, welcome back. I appreciate you being here. Thank you for hitting that play button. Let's go! Turn that up, turn that up. You know I love that when you do that. So great to have you. We're gonna get right into this, guys and gals. Focusing on the topic, and that is mathematics. It's great to have you here. We're doing mental math. I am Johnny with WhiskeyTango Sharp. Quite a mix of stuff going on over here between coding and Unity and mathematics. Doing it all. Yeah, I love it. I just want to quickly do I don't know, mod stuff, I guess, quickly. Coding and Unity. Sounds like we're good. All right, appreciate you guys being here. Here to support homeschooling parents, students. That's kind of what and why I'm doing this. Actually, I just enjoy, I guess, talking to you guys. We're talking to nothing. I don't know. Some of you are watching, I know. Doing it for you. I do enjoy mathematics, and I don't know. I just enjoy it. Getting older in that, not to age myself or anything, but I think this is good for the brain, just to kind of keep it working, I guess. For those of you that are younger, look at it this way, right? Some of you might be kind of resisting. Oh no, I don't want to. Oh, the humanity. Just look. How do I explain this the best way? So just accept it and enjoy it and love it while you're young, okay? And then when you get older, right? You're going to be using the math and using your mind and getting it working. Well, I don't know how to say it, but you're just kind of keeping the old gears a rolling, right? And it's good. I think it's good for your brain to kind of do that, just to keep things in motion. So look at it as something that you may not use it in real life, but there's quite a good chance that you'll be using it when you're older. Just to, it's good for the brain. It just really is. Okay? So let's do this. Let's learn. Let's grow. Appreciate you guys being here again. All right, where were we? We were working on a candy, more candies. Again, candies. What's with all the candy? All right, so what we have, the problem is, well, I don't know if it's a problem, but I mean, they're doing pretty good. 1 candy a day, that's pretty good. There are 60 candies in a box. If you eat 1 candy each day, how many candies are there in the box after 8 full weeks? Okay, 8 full weeks. Woo! All right, so we just have to figure out days, right? We're going to turn weeks into days. So we know that 1 week, oh my goodness, I don't know why I'm so parched. Let me have some coffee here quickly, guys and gals. Oh, goodness. Okay. All right. So 1 week has 7 days, right? Again, common knowledge stuff, right? We know this. So, but we have 8 weeks. So to figure out the total number of days, we take the number of weeks, just kind of explaining it, being thorough here, that's all, guys, gals. And we're multiplying it by how many days per week. So we're multiplying it by this. Okay, which is 7 days. So we take our 8 from here. Eight full weeks multiplied by the days. Again, hopefully you have your times table memorized, but we'll look at it. 8 times 7, you just connect things, pick a row. We're going to go with the 7 row, and we're going all the way to 8. So 56. Okay. Take a little bit, study if you're, don't have the times table memorized yet. It's here for you guys and gals. Again, if you've been watching the series, you can do this snipping tool. Okay. And just snipping tool it, save it, and print it off. And then you can kind of study it every day. Kind of before bed or whatever. It's recommended you go up to your 10s, but you could go a little bit more if you want. It's up to you. Challenge yourself. Go up to 12. Once you have all the going up to 10s done. A lot of them are easy, right? Anything times 1 is the same number. So you really don't have to memorize that. The easiest thing to do is just learn how to count by 2s. Learn how to count by 2s. Learn how to count by 3s. Learn how to count by 4s. Learn how to count by 5s. It's all consistent. If you do that, a lot of them you'll have memorized pretty quick. All right, best of luck on that. Let's continue. So, back to the problem. So they've eaten 1 a day. We can already kind of have an idea in our head what our final answer is going to be, right? Let's just go like this, right? We could do the mental math in our head. So they've eaten 1 candy a day. Took basically 8 weeks to do it. Well, almost. It'll be a little bit more than 8 weeks to do it, but here we go. So we have 60 in a box. We've eaten 1 a day. All the way up to 8 weeks, we've eaten 56. So now it's just a matter of quick subtraction, right? I'll show you the kind of the long math here. We're borrowing from the 6. The 6 becomes a 5. The 0 becomes 10. 10 take away what, right? This is why I show you guys and gals this. 5 and 5. 6 and 4, 7 and 3, 8 and 2, 9 and 1, right? So then you could quickly math in your head, because you know these all equal to 10. You could quickly do it in your head. 6 and 4, our answer is 4. Okay? And that's the correct answer. There's 4 candies left. So you only have 4 more days of candy. And that is it. Again, make sure you brush your teeth every night. Let's go. All right, clean things up. Okay, here we go. Let's keep working, guys. Right, we're sticking to the teaching here. Straight mathematics. That's what we're talking about. Again, I have to remind myself to stay on track as well, and that's what I want to do for you parents. Stick to the topic, and the topic is mathematics. We're working on basically gross pay, time cards, percentages, and those sort of things, okay? Mental mathematics, and this is kind of for fun, guys and gals. I want to finish this up, and then we're going to get back to doing basically grade 9, grade 10, grade 11 mathematics. So it's great to have you. Appreciate you being here. Again, if you like the content, hit that like button. You know, that helps out with the channel and the algorithm and that. I don't know how it all works. I try to put, common search words and such on the videos. So, like, for example, whatever people are going to search. I don't know. It's all kind of a guessing game. So it doesn't seem to be working, but I still do it anyways. But again, sharing is caring, liking, and supporting the channel. That's how it grows. Appreciate to have you guys and gals. I just, I can't get my words out, I guess, today, but it's just great to have you. It truly is. All right, let's continue. Complete the following pattern. Okay, so we just got to do a little thinking. Okay, so we have 60. Our next number is 75. And this is an unknown. And then we have 105. And then we have another unknown. Okay, so it's fill in the blanks. So the smartest thing to do, guys, gals, right? It's kind of like, what I just said with the times table. If you learn to count by 5s, you'll have the 5s down, right? And we could continue 65, 70, 75. Basically, if you look at the pattern, and I always say this, numbers are patterns. They really are. And it's very consistent. The patterns are consistent. We have 10 and 5. We have 0, 5, 0, 5, 0, 5, 0, 5, 0, 5, 0, 5. That's the pattern, okay? Counting by 5. So essentially it'd be 5, 0, 5, 0, 5, 0, right? You see the pattern? Okay. I'll go back to here. So we look at this and we go, okay, we're kind of counting by 5s, but not really. So we know if we add 5, we get 65. If we add another 5, we get 70. If we add another 5, we get 75. Okay, there we go. There's kind of a pattern. So 5 times 3, or 5 plus 5 plus 5, it's all the same thing. We get 15, right? So that means between 60 and 75 is 15. We could do the longs. We could do the long subtraction if you like. We can, right? So this number is larger than 0, so that's what we want. So we could straight subtract, which is basically you're just dropping the 5. So and this number is larger than 6, right? Again, the top numbers have to be larger than the bottom numbers, and you can just straight subtract. No borrowing, okay? 7 take away 6 is 1. There's our 15. So we could go like this. We could go, okay, well, there's a possibility the pattern is by 15s, like counting by 15s. So let's do this. Let's go 75 plus 15 will give us our next number. This number here. Okay? This is where we are right now. So let's add, because we're increasing, right? 5 plus 5 is obviously 10. Carry the 1. 7 plus 1 plus 1. So 7 and 2, which is 9. Okay, so technically speaking, our number is 90. Okay, but we're not 100% certain that it's counting by 15s. So to confirm that, we could just go 105 take away 90, just to confirm. And if it's true, then that means we are counting by 15s. Okay, so we could actually subtract, straight subtract. This is greater than 0. Perfect, that's 5. 10 to take away 9 is 1. Boom, it is in fact 15. So we're counting by 15s. So that means this answer is correct. So now we could go 105. Again, this is kind of, you're going to need a scrap piece of paper, and you're going to be kind of doing this on the side. Again, you could use Krita if you want. So now here we go. We're adding, right? So we're increasing. So now we're here. 5 and 5 is 10. Carry the 1. 1 and 1 is 2. Drop the 1. We have 120. Okay, so those should be our numbers. Okay, let's have a look. All right, let's drop the A's. That's it. That's the pattern, guys and gals. 90 and 120 are the correct answers. All right, let's clean things up and continue. All right, next problem. Angles. Ooh, I love angles. Okay, is an angle of... All right, we kind of been over these already a few times. Okay, so angles kind of work like this. Whoops. Wish I could draw better straight lines. I'm going to try. Ooh, that's pretty good. Not bad. All right, there we go. So just a familiar, we don't really need to know this stuff yet, but I'm just trying to get you guys and gals used to this, okay? When you're working with grids, like I don't want to, or graphs, I don't want to scare you, but the common things you'll see is X and Y, okay? X and Y. Now, if we go to our, let's see, integer grid, let's see if I can bring that up quickly. Let me rotate this, right? So going over the integer grid, I could cut this piece. You guys could actually snipping tool this if you want, and then it's just a matter of cutting this in half, and you're just connecting the zeros is what you're doing here, okay? Use some Scotch tape or whatever and just kind of connect it if you want. Excuse me. So if you look, 0 is our center, okay? When we're talking about integers, you have positive integers and you have negative integers, all right? When you're going to the right, if you notice the pattern is, I didn't write in 1, I didn't write in 3, but we're counting by ones. 1, 2, 3, 4, 5. Each tick is one jump. Okay? From 0, you're going to the right, it's increasing. And these are all positive numbers, okay? Now here's the 0 again. To the left, if you see the pattern, all the numbers are negative, but going to the left, they increase in numerical value, okay? If we're not looking at the sign, you can see that in numerical value, they're increasing, going to the left, okay? So the reason I brought that up is it's no different with a grid, okay? So we actually can go this way. This is our center, essentially. It's called the origin, and the origin is 0, 0. Okay, right there. This intersection, that is that. And that's called 0, 0. Okay, so that means all values going to the right are positive, and all values going to the left are negative. This is still x, okay, but it's negative x. Okay, and it's the same thing with y. Vertical is positive, going down is negative. Okay? All right. Back to the problem. So I'm just kind of getting you familiarized with angles in kind of x and y grid coordinates type stuff, right? You don't need to know it now, but it doesn't hurt to be aware of it, to kind of have an understanding. Again, we'll be going over it more and more and more. Repetition. That's how you sink it in the old membrane. Okay? All right, so the question is, now the reason I bring that up is because we're going to be talking about angles. A lot of this has to do with angles. You might have a line that's like that, that's in this quadrant. These are called quadrants. This would be called quadrant 1, where it's positive in this quadrant. X is positive, Y is X is positive, and Y is positive in this quadrant. Okay? All right. So, angles also start, like, imagine there's a line here just kind of laying flat. Okay, this is 0. Okay, this would be 90. Now, if you are familiar with circles, right, I'm just going to go like this, right? This would be 0, this would be 90, this would be 180, right? And then plus another 90 is 270. If you notice, it's counterclockwise rotation. Counterclockwise. It's very consistent, okay? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? So the angle that they're saying is, and this is why I'm explaining this, so you guys understand, right? We're going from 0 and we're rotating counterclockwise, okay? Counterclockwise. From here, counterclockwise. Okay, just get used to that. That's kind of how it works, all right? All right, so the angle they say is 235. So looking at this here, that means 0, 90, right? Again, I could show a 90-degree angle. You'll see that little symbol, that means 90 degrees. Okay, so they're saying the angle is 235. So that's going to put us between 180 and 270. So I'm going to kind of guess, like, what's how 245. Let me just see. 180 plus 45 kind of puts us at 225. So it's a little bit more than halfway. So I'm just going to kind of exaggerate it. There's our line. Okay, our line went from here all the way to here. There we go. Okay. It started flat here and just rotated. Okay, and here it stopped. So from here to here is 235 degrees. Okay, I could put in a symbol here. It's called theta. You really can't see it, but it's kind of drawn like that. Something like that. Called theta. And that is 235 degrees. Okay, we're just trying to keep it simple here, guys, okay? So the question basically is it an acute triangle? Is it an obtuse triangle? Is it a right triangle? Is it a straight triangle? Or is it a reflex angle? Why did I say triangle? Sorry, guys. I meant angle. Technically speaking, if I drew a line here, I just created a triangle. Okay, so essentially you can envision a triangle in there, and you'll see this kind of stuff. Okay, all right. So now we have to ask ourselves. So we need some diagrams. Okay, and I have some diagrams for you. Let me just bring it up here once I find it. Ooh, is that not it? I thought I had it in here. Uh-oh. Well, I have it, but I just gotta find it. I'm looking in a different folder here. Bear with me, guys. Maybe it is in here. Okay, hold up. Where am I looking here? Is it in here? Please tell me it's in here. Oh, yes, I found it. There we go. That's what we're looking for. Okay. So here we go. Familiarize yourselves with the triangles. Okay, these are common. So equilateral, if you see these ticks, basically the ticks mean all three sides are exactly the same length. Okay, if you measured it, they'd be all the same length. So they're equilateral on all three sides. All angles, all interior angles of a triangle add up to 180 degrees. Okay, half a circle. All right? Little things to remember. Isosceles, only the left, these two sides are the same. Okay, this isn't. Then you have scalene. Obviously, all three sides are different lengths. And then you have a right triangle. Memorize that. A right triangle is a 90-degree triangle. Okay? And then you have an acute triangle where, obviously it's, these interior angles are less than 90 degrees. Okay? And they could have same lengths, different lengths. There'd probably be different lengths. And then you have an oblique one where if we drew a vertical line, you can see that this line is actually greater than 90 degrees, which would technically speaking put us into this quadrant. So just looking at that, we know oblique is not the answer. They're saying acute. Okay, look at this, acute. Is it an acute angle? No. Because an acute acute one, because it's cute. Where's that? Right here. There it is. Right? This is the line we're looking for right here. You can see it's less than 90 degrees. Okay? So, not true. So, it's not acute. Is it obtuse? Obtuse. Do we have an obtuse in here? What is an obtuse, right? So we might have to Google search Do I have a diagram on one? I don't. I wish I did actually. What is an obtuse triangle? Okay, in geometry, I guess. In geometry, an obtuse triangle is defined as a triangle where one interior angle measures more than 90 degrees. Okay, so there we go. I should write it on here. Oh goodness gracious, Sally on Sundays. Let me do this. I should actually fix it for next. Can I edit it? Open with Paint. Let's do that. Okay. So I'm just gonna do this quickly. Obtuse. Okay, obtuse. Where one interior angle measures more than 90 degrees. Okay, that's this one. So now I just need to kind of resize this. And maybe I should change it to a different font. I don't mean to kind of do this on the fly, guys and gals, but hold up. Let me just, let me close this. And then I'm just gonna copy this, paste it here, rename, and I'm gonna go like this. I want to keep the original. Whoops, open with Paint and start again. Obtuse. And change the font to where's the font? Why can't I see? There it is. They changed this program slightly on me. There we go. That'll work for now. Is the size? Go up a little bit more. Okay, there. That's an obtuse. Okay, close enough. Okay, so what's the next one it asks? A right triangle. Okay, we have a right. A straight. Okay, a straight. I don't really have to. I can't really show that, but we'll just. What is a straight? I guess it would be a straight angle. A straight angle. Straight angle. If you think about it, straight is kind of a straight line, right? So we'll kind of look at this. So a straight basically is this line right here. Except this is really the line that they're talking about because it's from 0 to 180. Okay, so in geometry, a straight line is an angle that measures exactly 180 degrees. Okay, so if I was to draw it, that's essentially it right there. That's a straight line. So it's not a straight line. It's obvious. Okay, what's the next one? Or a reflex angle. Okay, let's ask, what is a reflex angle? Okay, now to look at my little, I don't really have an actual triangle for that one, but we do have this line here. So a reflex angle, I should actually have these definitions somewhere for you guys and gals. Let me just actually copy this. I wonder if I could go like this. And then I want to maybe make that small. Let's go to 12. And then let's click back here. Whoops. There we go. I want to copy that other one as well. There we go. Straight. because I don't want to have to keep searching for this all the time, right? So I know it's going to be kind of hard to read here, but there we go. Okay, so I'm going to leave that just like that. Let's go, I don't know, like that, just to separate the two. And then maybe go like this. Can we fit that all in there? So it fits in better. There we go. Hope you guys and gals don't mind me doing that. So now I can save that. So I'm going to close that. And this way I can just double click and open that. And there I could kind of zoom it now. There we go. Save some time. Not having to search it. So our answer then is going to be reflex. Whoops, I just actually closed that. Oh, right. A reflex angle in geometry is an angle that measures more than 180 degrees but less than 360. So essentially it's going to be any angle that's in the, it's either in quadrant 1, my bad. Let me just write these. It's going to be in either quadrant 3 or quadrant 4. Okay? Reflex angle. So our angle 235 degrees is in fact a reflex angle. Okay, let's drop the A's. All right, there we go. Awesome sauce. Now let's carry on. A little bit of a breakdown on angles, kind of fun, right? I know I gave you guys and gals a lot of information. You don't have to have it all memorized, but the good part about it is now you have an understanding of it. You have a knowledge of it, right? Things you're going to actually come across as you kind of progress in mathematics, all right? Okay. Here we go. So we have another question called, it basically just says evaluate. Whoops. Let's spell things right. Evaluate. That's essentially what it says. Okay. So we are given 4 subtract 6 plus 2, and then they have a times here which you don't really need, which is really unnecessary because anytime you see brackets infers multiplication. Okay, so they have in brackets, subtract 8. Now the reason I got rid of the X, which is another way of writing times, I'll use the dot for multiply. But the thing is, I don't like using this because sometimes you can have a variable X. I write my X's like that, but that style X means times, but I'll avoid it because, again, you can have a variable X. So, anytime you see a number multiplied by something in brackets, just automatically, anything that's, here, let me write this so that, let me just clean that up. There we go. I want to get rid of that. 3, take away 8. Okay? Again, if you have a number, an integer, right next to a parentheses, automatically set it in your mind. This means multiply. Okay? You're multiplying whatever's inside the brackets by 2. Okay. Okay. Now let's focus. How do we solve this? This is something that people have troubles with. And this is really honestly basic stuff. Okay, now as you can see, I have a thing called up here called bed mass. I should probably erase it and fix it, but it's either written bed mass. I'm just gonna write this kind of quickly. Just depends where you are. You'll also hear it called ped mass. Okay. They mean the exact same thing. Really, the P and the B are these brackets. Okay? Brackets, parentheses, potatoes, potatoes, tomatoes, tomatoes. It doesn't really matter. It all cooks the same. All right? So the rules are brackets, exponents. So an exponent would be something like that, which we have none of, so we don't have to do anything. But we do have to solve the brackets. So brackets are first. Any division multiplication is next. And lastly, we do addition subtraction. Okay, so we don't really have to worry about the left side. You can kind of look at these as parts. This is part one, this is its own part, and this is kind of its own part if you break it up. Okay? So we're not going to do anything here yet. So let's just start with the brackets. Plus 2. Now we have a 3 take away 8. Okay, this is critical, guys and gals. This is critical, this part. It looks like it's easy math. Oh, you're probably going in your mind, oh, it's 8 take away 3, that's 5. No, you are in fact incorrect. Now, I'm not being mean or anything, but here's why. Let's look at our grid here, okay? We have 3 take away 8. I always, just ignoring the sign, I look at the larger number, okay? Our largest number is 8. And I like to do what's called jumps. I call it jumps. Okay, I want to start with the highest number, but I want to do the least amount of work or the least amount of jumps. So our least amount of jumps are going to be 3. So therefore, I'm going to start with this 8. But like I've explained before, guys, now I don't really need to show it this way, but technically speaking, what we have here is a -1 in imaginary brackets times 8. So this part right here is what I'm showing up here. So this negative belongs to the 8. Okay? So, in fact, what we're looking at here is an actual -8. So, with that said, I'm going to start at -8. Okay? Going back to the question, how many jumps are we going to be doing? Well, it's going to be 3. Now, if there's no sign, it's inferred positive. Okay? Again, this is kind of like if you're learning coding, you'll hear a term called explicit. This is explicitly saying that this is a -8. This sign right here means it's a -8. That's being explicit. If there's nothing here, if there's a negative here, that means we're explicitly saying it's a -3. But in our case, it's a +3, right? Inferred positive. All right? So, with that said, positive, whenever we have positive, whenever it's positive, we go right. Whenever the sign's negative, we go left. Okay? Little things to remember. You can write that on a scrap piece of paper if it's something you forget, or you can draw yourself a quick integer number line grid, you'll know, right? Again, 0 is center, everything to the right is positive, everything to the left of 0 is negative. Okay? In our case, we're going positive 3 jumps to the right. I'm just being explicit explaining this, right? This is important. This is how negative integers or how integers work, guys. So I'm going to start from -8 and I'm going to go 3 jumps to the right. 1, 2, 3. That's putting us at -5. Now I know I haven't written it here, but I'm not sure what I just did there, but okay. So we're at -5. 1, 2, 3, -5. Okay. Okay, so I'm going to write in here -5. Don't lose that sign. Again, like I said, this negative belongs to the 8. All right? That makes a lot of sense. I hope that helps. Okay, so now I'm going to still do the bracket stuff. All we've done so far is just kind of work the stuff inside the brackets. Now we have an actual number. We could actually multiply. So I'm going to go like this. As a matter of fact, I might have to clean up some of this here. Need some room here. Okay, I'm going to write it again. -5. Okay, so we haven't done anything here yet. This is just all hanging out for now. Again, addition, subtractions last, guys, right? So just ignore it. So we have a plus in a bracket 2 times -5. Negatives have a lot of power, okay? I'm just going to say that. Negatives, you don't want to forget your negatives, okay? If you forget your negative, you're going to have a wrong answer, okay? So now we know 2 times 5, right? We're going 2 times 5. Essentially, that's what we're doing. And we get 10, right? Now here what I've done, the way I've written it, I've forgot my negative, okay? Key, guys, key, all right? Key. Don't forget your sign, okay? That negative has a lot of power. It's important. So it's actually a -10. Okay, so I'm just going to carry my work up here. All right, so we have 4 minus 6. And then we have a plus a -10. Remember how I showed you earlier how with the 8, it was like, this is kind of the same thing, right? This is a 2 times, but anyways, remember how I was showing +1 times, I actually want to get rid of that plus. I don't want to confuse you. That -8, it's kind of like that, right? It doesn't matter what sign you have on this side, but essentially you have a plus 1 times the bracket. So it's the same thing right here. I could write the 1. It's imaginary 1, it's called. Okay? So there's an imaginary 1 right there. So essentially what we have is +1 times a -10. Again, our negatives have more power than positives. Okay? With that said, that means this plus sign basically gets deleted. So we end up with a -10. Okay? 4 minus 6 minus 10. So looking at this now, I could use the integer grid to do the math. I could. Having this is nice. That way maybe you won't make mistakes. But the way I look at it is like this. I'll put this. I have 2 negatives. So if I have 2 numbers with the same sign, I'll just add them together. This has a positive. Okay, that's a +4. Okay, so I have a negative and a negative. So we know 10 plus 6 is 16, right? And I'll show it to you, but here's actually how it works out. So I'm going to go 10 plus 6, which is 16. We're going in the negative direction, therefore it's negative. And then I just write 4. This negative still has a lot of power over the 4. So I can still go 16 because they have different signs. We're actually making this smaller. So 16 take away 4 is 12. I don't want to confuse you, but I'll show you the work. And in a matter of fact, again, like I said, this negative has a lot of power. Don't forget your negative. Our answer is negative 12, but let me show you the work. So I'm just kind of going backwards so you guys can see. So we're going to use our little integer grid. I'm going to start with negative 10 because it's ignoring the signs, it's our largest number. I want to do less jumps. Like, these are our jumps. So I'm going to start with the biggest number, which is negative 10, and I'm going to go negative 6 jumps. So we're going to start out at negative 10. Again, remember I said, guys, gals, when we have a positive, we go right. When we have a negative, we go left. Okay, that's really all you need to remember. That's key right there, what I'm teaching you. It's key. You won't mess up your integers if you remember that stuff. Okay, so negative 10, we're going negative 6 jumps. Again, that sign is important. That sign belongs to this number. Whatever is immediately right next to it, this sign belongs to this. This sign belongs to this. Well, there's no positive here, but technically speaking, that positive belongs to the 4. Okay? So negative 10, negative 6 jumps. 1, 2, 3, 4, 5, 6. That puts us at negative 16. Okay, so I'm going to write 4, negative 16. So with the rules that I said, right, when you have a positive number, we're going right. So, from negative 16, 4 jumps. Negative 16, 4 jumps. 1, 2, 3, 4. Puts us at negative 12. Okay, that's our answer. Big yays, guys. Big yays. Now, I did that so that you guys could visually see it. All right? That's the correct answer, 100%. So here's some other tips for you. Okay, let's say you're at negative 16. And if you're uncertain of the sign, here's something else to remember. You need 16 jumps in the positive direction just to get to 0. Okay? In turn, if you're at positive 16, you need negative 16 jumps just to get to 0. That's how you tell if you have the right sign or not, right? Or in the right specific area of your integer grid. Again, what I'm saying is, if you're at negative 16, if you're only doing 4 positive jumps, well, you're still going to be in the negative zone because you need 16 just to get to 0. All right, makes sense? I'm going to leave it at that because I think you understood. All right, let's clean that up. There's our answer. Whoops. How are we doing for time? I feel like this is going a little longer than it should. Yeah, we're getting up there for time. Time flies when you're having fun. Oh yeah. Okay. Next question. There are 3 pairs of socks in the package. Okay. So we have a package. which has socks. It says it has 3 pairs. I'm going to just kind of randomly draw. Okay? 3 pairs of socks. 1 pair, 2nd pair, 3rd pair. Now, when you hear the word pair, right? We all know this. This is common stuff. A pair equals, well, a left and a right, right? Sock 1 and sock 2. I know it's crude drawing, but that's okay. So that's 1 pair. Okay, so if the whole package costs $6, okay, so this is the whole package. So we have 3 pairs. And the package is $6, which is pretty cheap. Not to get off topic, but man, things are expensive where I am. It's crazy. How much does it cost per pair of socks? Per pair. So we don't need to know this, so this is really not important. But we do need to remember we have 1, 2, 3 pairs. Okay, we have 3 pairs. Pretty simple math, right, guys? So the question is, how much does it cost per pair of socks? So we have $6. We have 3 pairs. Reducing the fraction, we know that 3 times 2 and 3 times 1. So I broke it in parts. Really, that's what I'm doing. When you're factoring, guys, and reducing, this exactly means the same thing as this. This exactly means the same thing as this. We just broke it apart. We're kind of like, just breaking it apart in parts. But we need that common number, right? The common number is 3. Because we want to be able to cancel it. We want a numerical value of 1. Again, we know common rule, anything times 1 is the same number, right? 1 doesn't have much of a drastic change on any value, right? Okay, so that's why we do the factoring. So what we're left with is 2 over 1. Anything divided by 1 is the same number. So that means it costs $2 per pair. And that's a big A's. Okay, so let's do another one real quick. I want to try to finish up this little section so that it's actually done. If you have a little more patience, I appreciate that. So they're saying evaluate. I'm not going to write it down, but they're saying evaluate. It's kind of like, think of it like you're adding money together. Okay, so you have $27.50, which is not bad. We have $27.50. We're $27.50. We're going to pretend it's money. Remember, when we're working with decimals, okay, we're working with decimals. When you're adding or subtracting, you line up the decimals. Okay, so we have 10. The other number is 1075. Decimals are not so bad, guys, as long as you remember the little rules. The basic simple rules. If you're adding, subtracting decimals, line up the decimals. That easy. We're adding here. We could add, right, guys? Adding's easy. Okay, so again, we're not subtracting, so we're not borrowing. There's no reason for borrowing because we're adding, right? So 5 plus 0 is 0. Blah, blah, my bad. 5 plus 0 is 5. Okay? 7 And so we know 7 and 3 equals 10. 5 is 2 higher than 3. So that means 7 and 5 equals 12. So 2. Carry the 1. Bring our decimal down. 7 plus 1 is 8. Plus nothing is still 8. And then of course 2 and 1 is 3. So our final answer is we have a total of $38.25. Let's drop the yays. Right, guys and gals, remember? 5 and 5, 6 and 4, 7 and 3, 8 and 2, 9 and 1. This is how to help you guys and gals get that, right? We all know these add up to 10. Okay? That's why I went like this, right? There's our 7 and 3 right there. I know 7 and 3 is 10. 5 is 2 higher than 3, so that's 10 plus 2. That's how I got the 12. Okay? Let's carry on. Last problem. Actually, well, yeah, I'm going to finish it and then I'll leave you with another problem. Okay, let me go here. Okay, what is the question? The question is, you leave the house at 7:30 a.m. Okay? It's 7:30 in the morning. Okay? You return to the house. So I'm just going to draw a crude house. We leave the house at 7:30. Oh, I'm actually skipping a problem, but that's okay. There was 2 left here, and goodness gracious. Okay, let's do the other one real quick. I'm going to put this one on hold. So how many hours are there between 9 a.m.? So just ignore this. We're going to do this one real quick because I kind of skipped a problem. Okay, how many hours between 9 a.m. and 5 p.m.? I'm not sure if you guys can read a circular clock with hands. I'm not sure because I don't know if you know or not. Let me know in comments if you want me to teach you how to read a clock. I don't know. Some people out there don't know how, right? Not everybody knows everything. Okay, so this is what I do know. So if we go like this, okay, we know this is noon or 12 p.m. Okay, straight up and down. Okay? Technically speaking, it's p.m. Okay? This one right here. So from 9 to noon, because 9 is here, right? 3 is over here. 6 is down here. 9 a.m. Okay? From 9 a.m. to noon is 3 hours. Right? Because basically it's 12 take away 9. Right? Noon take away 9 is 3. Okay? So that's just to get us to noon. Okay? That's to get us to noon. So from noon to 5, well, that's 12. 12 is like, don't think of this, you're not going 12 plus 5 unless you're doing army time. Army time would be 1700. right? But it's actually 5 hours. So from noon to 5, 5 is obviously going to be somewhere around here, right? That's 5 hours. So basically, you just go 3 plus 5, which is 8. So between 9 a.m. and 5 p.m. is 8 hours. Okay? Easy peasy, right? Again, let me know in comments if there's anything you want me to kind of elaborate on. I'll do my best. Okay, now let's get on to this last problem so we can finish up. You leave the house at 7:30 a.m. You return to the house at 3:45. So you're back home at 3:45. That's a bit of an early day, right? That's not bad, I guess. So I'm just going to draw a little crude house. And we're back at home. Okay? Went to work. We're back home. Okay? How many minutes are you gone from the house? Oh my goodness. They really want to make us work. Okay? I'm going to leave this for you guys and gals to try to figure this out with the problem that we just did. Okay? You're going to have to do some rounding. Remember, from 7 to 8, right in the middle is 7:30. Okay? Other little notes. 1 hour. A lot of you probably already know this. This is common knowledge, but I'm going to write it anyways. 60 minutes. Okay? 60 minutes. Is that the question? How many minutes are you gone from the house? So essentially you're going to want to figure out how many hours between 7:30 and 3:45. You might have a fraction of an hour, okay, just to let you know. Right? 7:30 is essentially 7.5, right? Because half of 60 is 30, right? 60 divided by 2, equals 30, right? That's 30 minutes. That's mins. This is an hour. Half of an hour is 30 minutes, right? Okay, so that's your math, okay? So once you figure out the hours, then it's just a matter of taking them hours and multiplying it by minutes. Okay? I'm going to leave it at that, guys. Do another video for you. Appreciate you watching. Thank you for growing and learning. Even if it's just basic fundamental stuff, we're learning a lot of different things that we could do. A lot of mental math, just kind of figuring it out in your head without a calculator. Again, please understand, guys and gals, not everybody's at the same level. They might be new to learning a lot of this stuff. Either way, I appreciate you all being here. Johnny WhiskeyTango Coding / mathematics. I appreciate you being here. I'm going to leave it at that. I'll see you guys in the next video. Take care for now. And, peace!